Hey guys, welcome to lesson 512, day 1. Notice this typo. That's what copy and paste will do to you. So today we are going to build off of what we did last week, which was finding inverse functions from like original equations. And we're going to talk about what the graphs and tables look like when we are comparing them between like a regular and function and its inverse. Okay. So here we have a just random function, and we're going to go ahead and do what we did last week, which was, write the verbal description of it, write the verbal description of the inverse, which is like the backward steps, and then use those instructions to write our inverse function. So first we look at this equation and we say, okay, well, what's happening to this x here? The first thing that happens is that it's multiplied by this 2. You might have thought about saying plus 1, but you have to remember that in order of operations, multiplication comes before addition. So the first step has to be that you multiply by 2. Order is very important here. Okay, and then the next step is then adding 1. All right, so that is all that happens in my original function. So I'm going to go ahead and do the backwards inverse version now. And remember the process of unwrapping a present, right? Wherever we left off at the end, which was taping it shut, that's the last step when you wrap a present. In order to undo that, you have to start by opening the tape. So we start at the bottom and we work our way up with opposite operations. So instead of adding 1, we will subtract 1. Instead of multiplying by 2, we will divide by 2. And that is it for my instructions for the inverse. So we use those instructions, just like IKEA directions or something, and we create our mathematical representation of the inverse function. So let's start by writing that floating x, and then we do these things to it. So the first step is to subtract 1. So I'm going to go ahead and subtract 1 from that x. My next step is to divide by 2, so I'm going to go ahead and divide everything there by 2, and then that is it. I am all done following my steps, and so this is my final inverse function. All right, so now we are ready to form the tables and graphs of the original and inverse functions. So let's go ahead and go to the calculator to get this graph and table. Okay, we'll start with the original one. Notice how this one's talking about f of x, and this one's talking about f inverse of x. So f of x, I've already typed it in here for us. It was 2x plus 1. So we can go ahead and look at the graph. Although we're going to need the table first. We're not going to graph just yet. Press second graph for the table. And let me make this big. So here we have some good values. Let's take this from -2 to 2. So we have -2, -3, -1, -1. All right. All right, 0, 1, 1, 3, 2, 5. You guys hear my ice machine in the background. Okay, so this is my original. Let's go ahead and plot the points and graph this. Just as you guys know how. That's a really ugly point. All right, so here is my original function. I'm going to go ahead and draw a line through that. Okay. All right, so here is my original. Now let's do the inverse version. So for that one, I'm going to go ahead and type this new inverse function into my calculator. Go back to y equals, and I will type it with the first top portion in parentheses. That is very, very important, guys. If you don't have those parentheses, then it will not be the correct graph. Okay, I'm just going to go straight to the table this time. And let's go ahead and note down what we find. Now, here's something that I want to point out to you, though. For the sake of what I'm trying to show you guys, we're going to just ignore the decimal points and we're going to just use the whole number points instead. Okay, so what I mean by that is that I'll do -3, -2. And then instead of doing -2, -1.5, because I don't really want to deal with the decimal, I'm going to go to the next one instead. -1, -1. And then what was the next one? 1, 0. 3, 1, and 5, 2. And you'll see 1, 0, skip this one, 3, 1, skip this one, 5, 2. All right, so let's go ahead and plot this table as well. So left 3, down 2, left 1, down 1, right 1, up 0. Okay. Now this is our inverse line. All right. So the first thing I want you to notice is something interesting about the tables, right? If you look at this table and look at this table, hopefully you would notice that the numbers on this table are actually just flipped versions of this one, right? Here we had -2, -3. Here we have -3, -2. The negative ones are the same number, so you can't tell, but 0, 1, 1, 0, 1, 3, 3, 1, 2, 5, 5, 2. So the numbers flip-flopped, okay, in the X and Y positions. So the points flipped. Basically, what I mean by that is that the X and Y values swapped. Okay, and then, okay, this second question is supposed to say graph. In the graphs. Now this one is a lot more obscure. I wouldn't even expect you to be able to look at the graph and tell me what you're supposed to notice because it's not super obvious. But in this graph, there is a very important characteristic, and that is that there is symmetry going on. And the line of symmetry here is actually the very middle, like the diagonal line that cuts this entire graph in half. Okay, it's your most basic line, and that's the line with the equation y equals x. Okay, that's the equation of that line, and that is, again, your most basic line that you can come up with on a graph. And it goes through the middle, and it cuts directly through every single, like, middle point on your axis. Okay, so if you look closely, you'll see that this purple line is a perfect mirror reflection of the red line over this pink line. So if you remember back to geometry, when we talked about line of symmetry, that's the idea that we're going for here. Okay, and in this case, that pink line is the line of symmetry. And this is something that will always be true whenever we are talking about inverse graphs. So if I want you to tell me whether two graphs are inverses of each other, you have to look for the symmetry over that particular line. It's always the y equals x line. So what did we see in the graphs? Well, they're symmetrical across the line y equals x. It's always this line. All right, next example. Here I have provided for you the function, its inverse, and also its graph. So our goal here is to create the tables. So for my first one, let's just go ahead and go back to the calculator and graph that first function to see the table values. So I'm just going to see if I can just adjust. Oh, nope. All right. All right, so I've typed it just as I see it here, and let's go directly to the table. Make it big again. So let's start at -2 again. So -2, -2, -1, 0, 1, 2. And my values were -192, -81, -24, -3, and 0. All right, now the cool thing here is that we don't even need to type this inverse function in our calculator. We could if we wanted to, but we don't have to because of what we just learned, right? We learned that the inverse table is actually just the flipped version of the regular table. So I can just swap the two columns to find a good table for my inverse. So notice how I just took this output column and turned it into my input column for the inverse, and then I'll do the same thing for the other one. Take the input column and it becomes my new inverse output column. Okay, and then just wanting you to notice on this graph, this is a really good graph because you can very, very clearly see the symmetry that's happening across this line. Remember, this is the y equals x line. And if you look at this green line, this red line is a perfect mirror image, mirror reflection over this line. And that's how you know that they are indeed inverses of each other. If the symmetry was not there in these graphs, then they would not be inverses. And there are questions like that on your practice problems for today where it'll just give you a graph and ask, are these inverses? And you have to look for symmetry across this line. Okay? That is all for today. Make sure you give the practice problems a try and let me know if you have any questions.